So in 4.3, we're going to look at graphs of exponential functions. And what we want to look at first is our initial value. And then we're going to determine if the function is representative of exponential growth or exponential decay, which means we're going to look at the growth rate. So a few things first, looking at this one, and looking at this one, and looking at this one, and looking at this one, we all see that our initial value on these four is 2. Okay, so looking at the initial value here, this value right here is at 0, 2. So you're looking at 1, 2, 3, 4 graphs that pass through this point. Okay, the next thing that you want to look at is the initial value here. This has an initial value of 4 as well as this. So in other words, if your x is 0, then this value to the 0 power is 1 times 4 is 4. So if you input an x value of 0, it will output a y value of 4. So you've got two options that fit these models. So now let's look at growth and decay. This one is between 0 and 1, so this is decay. That means he'll be decreasing as you read it from left to right. It's dropping. This one is between 0 and 1. It is decreasing, and so this is exponential decay. It will drop as you read it from left to right. On this one, it's bigger than 1. So you have 100% plus a 28% growth rate. So this is exponential growth. So as you read it from left to right, it will grow. Okay, it will increase. This one is going to be a 1.59. So it's your 100% plus a 59% growth rate. So this is exponential growth. As you read it from left to right, it will be increasing. This one is going to be an exponential growth model with a growth rate of 28%. This one is exponential decay, okay, because it's between 0 and 1. And then in class, we'll talk about who is steeper and who is flatter. So that is your exponential modeling. And then we'll do these ones in class as well, but let's just get a starting point first of all. I would like to know horizontal asymptotes. Is there a line that's imaginary that's guiding your graph? So if you look at that one, if you look at this one, is there an imaginary line that's guiding your graph? So in both cases, I could have a horizontal line that would slice through the y-axis at 0. Okay, and that is going to be your horizontal asymptote. I would like to know end behavior. So end behavior tells me what is the graph doing as I go to the left and as I go to the right. So as I go to the left on this one, my graph is going up to positive infinity. As I go to the right, it's going effectively to 0. It will never hit 0, but as I move to the right, my function is heading towards 0. That's another reason you got decay. It's going to 0. As you go to the left, this one is going to 0. It will never equal 0, but it's headed that direction. As you go to the right, it will be going to positive infinity. This is growth, exponential growth. So again, 100%, but a 67% growth rate. Okay, so your initial value is 5. Your initial value is 1. It's implied. What's your range? What's your very, very, very bottom y value? Your bottom y value is going to be 0, but you cannot use it. Okay, so it's going to be a soft bracket at 0, and you're going to have a range all the way up to positive infinity. Okay, what is your very, very, very bottom y value? It's going to be approaching 0, but never touch. So you'll have a soft bracket or parentheses at 0, and then it's going to be going up for its entire life. What's your y-intercept? What's my coefficient? It's 1. What's your y-intercept? It's 1. Okay? That's also your initial value. So if x is 0, you're going to have the 0.01. Okay? And then finally, you have an initial value of 5. If you evaluate your x at 0, 1.67 to the 0 power is 1. 1 times 5 is 5. So if you evaluate at 0, your output will be 5. Okay, so that's your y-intercept. And we'll cover more detail in class on Wednesday.